Alright, ladies and gentlemen, welcome to the video notes for Chapter 7, Section 2 in your McGraw-Hill Geometry textbook covering similar polygons. This is the first of two videos for this section. This video will cover similarity in general, what a similarity statement tells us about a pair of polygons, and we'll show a few examples of how to use that information. So, starts off with a vocabulary word, and that is similar polygons. Okay, similar polygons are two or more polygons which are the same shape but not necessarily the same size. Not necessarily the same size. There is a mathematical symbol for the word similar, and that is the tilde that we're used to seeing over our congruent statement. This is the mathematical symbol for is similar to. Anytime we see a similarity statement, what that tells us is that the sets of angles that correspond are congruent to each other. But the side lengths are no longer congruent. Instead, they are proportional. So, what does that mean? Well, what that means is that this similarity statement tells us that angle A, which is the first in the first name, is congruent to angle E, that angle B is congruent to angle F, that angle C is congruent to angle G, because they're both third in the name, and that angle D is congruent to angle H. So just like a congruent statement, we can use the positioning of the letters in the names to establish congruent statements for the angles. Now, the fifth thing that it tells us is the new thing, okay? Because side lengths, they don't match up as congruent in a similarity statement. Instead, what they tell us is that they still correspond according to the name, but instead of being congruent, they're proportional. Here's what I mean by that. Okay, AB and EF are the first two letters in each name. So the ratio AB to EF is equal to the ratio BC, which is second and third letter, to FG, is equal to the ratio of the last two letters, CD over GH, is equal to the first and the last letters, AD is to EH. That D is a little round for me. I think I'm going to erase it and try one more time. Okay, so this is called an extended proportion. Essentially, you would be allowed to use any two of these fractions, any two of these ratios, to set up and solve a proportion, because they are all proportional to each other. They are all equal ratios. Okay, so first type of problem you're going to see is they're going to give you a similarity statement. They're going to ask you to write out exactly what we just wrote out, the angle congruent statements and the side proportion. So if triangle FGH is similar to triangle JKL, list all pairs of congruent angles in a proportion which relates to the corresponding sides. So again, we can go to our picture right away and use the name to mark the congruent angles. Angle F is congruent to angle J because they're both first in the name. Angle G is congruent to angle K because they're both second in the name. And angle H is congruent to angle L because they are both third in the name. So we can go right away and we can say angle F is congruent to angle J. Angle G is congruent to angle K. And angle H is congruent to angle L. Those would be our angle congruent statements. That takes care of the first half of the problem. Now the side proportion is a little bit trickier. Not a whole lot trickier, but a little bit trickier. We have to go up to the name or to the picture, and we have to figure out which sides relate. Okay? So FG relates to JK because that's the one mark and the two marks at the ends. It's also the first two letters in the congruence statement. So either way, or the similarity statement, either way, we should be able to set up the proportion and say FG is to JK, because those are the first two letters in each name, as GH is to KL, because that's the second and third letters in each name, as FH, that's the first and last letter, is to JL. Since it's a triangle and there's only three sets of sides, their side proportion would contain three ratios. That does it for that example. Okay, if two polygons are similar, then their sets of corresponding sides will be proportional. We've already said that. The simplified ratio in that proportion, because they're all equal to the same, they're all equal to each other. So if we reduce those ratios, if we put them in simplest form, that simplified ratio is known as the scale factor. Scale factor is also something we should have some experience with from junior high. So here in this particular problem, we have a similarity statement. ABCD is similar to EFGH. That gives us the proportion AB is to EF, first two letters in the name, as BC is to FG, that's the second and third, CD is to GH, that's the third and fourth letter in each name, as AD is to FH. That is the last two letters in each name. Okay? So what we're going to do is we're going to take that extended proportion and we are going to plug in the side links from the picture. Okay? So we're going to plug in the side links. So let's see here. AB is 9 units. EF is 15 units. BC is 3 units. FG is 5 units. CD is 9 units. GH is 15 units. AD is 3 units. And FH should be EH. That should be EH. There we go. EH is 5 units. Sorry about that. There's a typo there. That should have said EH. First and last letters. Notice that when we reduce all fractions, we have this one and this one can be reduced, so we reduce them. And we get 3/5 equals 3/5 equals 3/5 equals 3/5. They're all the same. This is the scale factor. So we would say the scale factor of, and this is important, ABCD to EFGH is 3:5. Now, it is worth noting, by the way, that that is not the only scale factor. There's also a scale factor of EFGH to ABCD. In other words, we're flipping which one comes first in the name. Now, when we flip which one comes first, we flip which number comes on top. So the scale factor of EFGH to ABCD would be 5:3. So it is important that you watch your wording. Generally speaking, when we say scale factor, we go back to the similarity statement. Since ABCD came first in the similarity statement, its side links go on top in the proportion, which means that the scale factor would be 3:5. Okay? All right. One more slide and we'll call it a video. Determine whether these triangles shown are similar. If so, write a similarity statement and a scale factor. Explain your reasoning. So in order to show that two shapes are similar, we have to show that their angles are congruent and that their sides are proportional. So what we do is we go in here and we say, first of all, we need to confirm that the angles are congruent. Okay, so we're going to confirm that the angles are congruent. We're going to do that by writing out the three angle congruence statements. So in the picture, we have angle N is congruent to angle R because they each have one mark. We can confirm that angle Q is congruent to angle S because they each have two marks. They're already marked as being congruent, so we don't need to worry about confirming it. It's already confirmed. We've just got to state it. And then angle P is congruent to angle T because they have three marks. Now, we don't really need that third set of marks. That's why they're in red. Because in theory, if we know two sets, then the third angle theorem would allow us to state that the third angle is congruent. So that has confirmed angle congruence. Okay. Now, the other thing we have to do is confirm that the sides are proportional. Okay, so first we ask ourselves, okay, how do things line up? Well, NQ has to compare to RS because those are the marks between the 1 and 2 marks, right? See how this 1 and 2 at the endpoints? 1 and 2 at the endpoints. So the 12.5 has to compare to the 10. That has to be congruent to, or equal to, QP over, since that has 2 at one and 3 at the other, ST. And that has to be equal to PN, or NP, over RT, because those are the ones that have 1 and 3 at the endpoints. Okay, so we've got to make sure that these are equal. Okay, we're checking this. So we plug in the side lengths. 12.5 is NQ over 10. We're asking ourselves, does that equal 11.5 over 9.2? Does that equal 15 over 12? And it's as simple as we actually divide these to see if they're equal. So 12.5 divided by 10, that would be, okay, we're actually going to divide. So 12.5 divided by 10 is 1.25. 11.5 divided by 9.2 is 1.25. And 15 divided by 12 is 1.25. They are all equal, which means that it does check out. They are proportional side lengths. So since they are equal, the sides are proportional. Okay? Now, as for the scale factor, we have to ask ourselves, what fraction is equivalent to 1.25? So our calculators are capable of converting, but the scale factor would be 1.25 as a fraction, which is 5 over 4, which allows us to answer the question. We say yes. Triangle, and we line up the letters here, so it doesn't matter how we name the first triangle. Let's call it NQP, is similar to triangle. Remember, the second name has to match the first name. So since we went NQP, our second triangle has to be named RST. And the scale factor of NQP to RST is 5 to 4. That would answer that question. This is where the first video is going to end. We do have more information to cover in this section. That will be covered in the second video. Thank you very much for your time and attention.